Alright, let's move from the first into the guided practice here. So remember earlier that we have two different types of graphs that are going on. We have growth and decay. So growth model is A. A is your starting value. On the test, that's usually, they call it like an initial investment. They may also talk about it as the principal. Any of these words, like an initial amount, starting value, principal, any of that is going to be what A is. It's what you start with. And then you've also got an exponential decay model over here. Anyway, so R is going to be the percent rate of increase or decrease. They're talking about R here. What's the percent rate of increase or decrease? Because they're going to ask you that specifically. Like here, part B. What is the percent increase of the value of the car, or the percent decrease? So we got to figure that out. You're going to have a percent increase if it's 1 plus R, if it's a growth model. In other words, if your base is bigger than 1. You're going to have a decay model if your base is between 0 and 1. And we're going to use 1 minus R for decay. So that'll help us out with part B here. Alright, I've got two quick examples. One of them is growth, one of them is decay, and then we're going to practice. So tell what of the model represents exponential growth or decay, and then tell me why. So the value of a car can be approximated with this equation. T is number of years since the car was new. So here's the new car, and look at it, its value is all the way up here, everything looks good, and over time, because we're driving it, we're using it, we maybe got into an accident or something, the value of the car goes down. So this is going to be a decay model. You can also tell it's a decay model because 0.85 is between 0 and 1. So we know this will be decay. And just look right over here. So this is a decay model because base is between 0 and 1. And that'll get us to where we want to be. It tells us, is this a decay or growth? And then we justified it. The justification, B is between 0 and 1. Alright, let's look at the annual percent increase or decrease. This is a decay model, right? So we're going to look over here at your decay model. Percent increase and decrease is going to be 1 minus R. So we'll say 1 minus R. And we're looking for the percent decrease, and that's going to be right here, so 0.85. 1 minus R equals 0.85. When you work this out, when you solve it out, that means R equals 0.15. In other words, 15% rate of decrease. Each year, your car will lose about 15% of its value. Every single year. The very last thing they asked us to do is to estimate when our car will be worth only $8,000. So we're talking about 8,000 is 25 times 0.85 to the T. They want to know when our car will be worth $8,000. So we're going to take this function right here. We're going to graph it, and then we're going to go to a table. Alright? So we're going to go to the graph first. Alright, the graph is 25, open up a parenthesis, 0.85 to the x power. If you need to raise something to the x power, again, you're going to come over here to the raise to the power button and then press the x button at the bottom. Alright, 25 times 0.85 raised to the x. Hit enter. And yeah, you can see it up here in the corner. Up here. We don't need the graph really, all we need is the table. Okay? Because we're trying to find when we make 8,000, so that's on the y side. So we're looking for where y is equal to 8, and we're going to say like whatever that x number is. So go down to y where y equals 8, there it is. And that happens when x is 7. So the car value is $8,000 after 7 years. Okay. And again, they say estimate here, which is why I'm able to say, okay, even though it says 8.014 here, I'm going to call that 8 and I'm going to call that 7. So the value of the car is $8,000 after 7 years. That was our exponential decay. Now let's look at an exponential growth one. A great example right here, world population. For example, when are we going to run out of oil, or when will we as a species run out of food or water or something like that? That's all exponential growth and decay. If we need to write a model for it, they're asking us to write the model. That's fine. We just need to know if it's growth or decay. It's going to be a growth, so we need to use this template. Y equals a to the 1 plus r to the t. Now let's fill in all of the pieces of information that we know to figure out what we're going to solve for. The population is y, and we're measuring it in billions. So I have t and y. This is population in billions. And on the t side, this is time in years. Okay, so r to the t, y equals a times 1 plus r to the t. How much did we start with? We started with 6.09 billion. How much of a rate do we have here? We say the world population increased by about 1.18% each year. So 1 plus we're trying to get 1.18% into a decimal. To make a percent into a decimal, you're going to want to go left 2 places. Yeah, move the decimal to the left 2 places. So 1.18% is 0.0118 as a decimal. That's what goes in here. And then we're going to raise that to the t power. How much time has gone by? Well, we started at 2000, and they want us to estimate world population at 2005. So 5 full years have gone by. We're going to take this, just like we did last time, y equals 6.09 times 1.0118 to the t. We're going to take this equation, we're going to put it into our calculator, and then we'll estimate out at 5. Okay, so you're going to come over here, and you just want to get into a new graph and put in your equation. Your equation is 6.09, 1.0118, raise that to the x power. Okay. Again, you can't really see the graph. All you can see is like a little corner piece up here, a little line, and that's totally fine. What you're after is the table. Go to your table, and then they're asking for what is the world population in 2005. So that's 5 years later. The world population is 6.458. So in 5 years later, 6.458 is what you get. So at 5 years, population should be 6.458 and then billion people. Sorry about that. Okay. At 5 years, that's right over here, at 5 years, the population should be 6.458 billion people. Part B, estimate when the world population was 7 billion. When did that happen? So 7 billion is 6.09 times 1.0118. They're asking, when did that happen? Again, we can just look at the table and we can say, okay, when y is 7, so let's go with where y is 7. Here it is. When y is 7, x is 12. So 7 billion happens when we are at 12 years. So about 12 years, population is 7 billion. So we'll have a time right now to ask and answer some questions from the substitute, and then what we want to do is finish up your 2 problems on the back for your practice. When you're ready to go, I want you to check that practice, and then I'm going to send you into your homework. Your homework is the worksheet that has both day 1 and day 2 on it. So it looks like this. Here it's homework 7.1, day 1. If you flip it over to the back, homework 7.1, day 2. After you finish up your practice, you're going to check your work, and then I want you to start on your homework with the rest of the time in class. You're going to work on that until we finish up, okay? Alright, and then I will see you again on Tuesday.